Hey guys, today we're talking about separating mixtures. So separation of mixtures is what we're going to talk about today. So we mentioned two types of mixtures, homogeneous and heterogeneous. So let's look at a couple just as a reminder. So if you remember, heterogeneous mixtures aren't evenly distributed throughout. So what I've got here is I've got a beaker, got some beans. So I got some different types of beans. If I throw them in this beaker, give them a nice stir, what you'll notice is none of the beans stay at the bottom, water stays at the top. Don't mix really evenly, so we got a heterogeneous mixture. As opposed to something like this, we got a beaker, take a little bit of salt, throw it in there. Now at first, I don't know if you can see, but at first the salt just stays at the bottom. But if I give this a little twirl, as we know, that salt's going to dissolve. And once it dissolves, that salt breaks apart and is mixed evenly throughout. So now the other type of mixture is homogeneous, what we call a solution. Alright, so going through your notes, here we go. Alright. Remember, mixtures are combined physically. Alright, therefore we can separate the components into their original parts. Okay, we can get back to substances. And there are different ways to separate them, okay? And that's what this is about, is how do we separate these mixtures? So, talking about heterogeneous, well, if you remember, there are two types of heterogeneous mixtures. There's suspensions and colloids. This one right here is definitely a suspension. Remember, suspensions settle out. So how can you separate some of these? Well, this one's pretty simple. I can actually just pick out the parts in this one, right? Just spill a little water out. So I can actually pick out one of the beans and pick these out and separate them from the water if I wanted to. Okay, put that over there. Don't mess with that anymore. Another example is, well, let's say you had something metal that's made of iron, so like iron and sand. You can actually use a magnet, okay? You can actually put a magnet in a baggie, run across there, the metal parts come out, separate the sand and the iron. Another cool thing you can do is there's actually, if you go to really sandy parts like a stream that's kind of dried up and stuff, you can take a strong magnet and run it in a baggie, run over it and pick up little parts, and if you find a really, really small, perfectly rounded part, you can actually find little bits of meteorites. That's right, stuff falling from space in the sand. So it's kind of a cool thing to do. At least it is to me. Alright, again, we can pick out mixtures. You see there, if you have coins and cash, you can pick out the coins and take your cash. Alright, next up we have filtration. So another way to separate your mixtures is by filtration. So if I can get this thing to go, here we go. So we have some filtration we look at here. Now filtration is also used to separate a heterogeneous mixture. You could filter your beans and water out if you wanted to. However, it's probably easier to pick them out. This is for usually like a little bit smaller particles, but still enough that can get caught. So as you can see in the picture here, all right, what's happening over here is you are seeing that we're dumping our heterogeneous mixture into a filter with filter paper on it, all right? And the liquid comes out and the solid is caught by the filter. Now, this is done all the time at home, especially, well, a lot of students probably do this too, but especially by parents that wake up early for coffee. We use coffee filters, right, to filter out the grounds and you get your nice cup of coffee. So the large particles stay behind. And there's a term here, you might want to underline this or circle it or whatever. The liquid collection after filtration is called the filtrate. So this liquid down here that's caught, right, after you filter it is called the filtrate. So that's filtration. Moving right along with distillation. Right, now we're looking at a homogeneous mixture. So, got my salt water. Be really hard to separate this, right? I can't go in here and pick out the salt because I can't even see it anymore, right? And I can't do it through a filter because actually the salt particles are now dissolved in the water and actually will go straight through the filter. So you can't filter salt water. So Here's a distillation setup, and here's basically what happens. You put this on a hot plate, it boils. The water will boil off, and it will actually leave the salt behind. Okay, so the water will boil off, leaving your salt behind. So this process is used based on the physical property of boiling point. Okay, so we actually use this based on boiling point. So the water comes out here, it actually will cool off in this tube, come over in this flask over here. You have your liquid water, you'll leave behind your salt, and now you've separated your salt water. Oh, chromatography. Chromatography is one of my favorites. All right, chromatography is separating a solution across a porous surface. Sometimes you can use filter paper for this. They also have chromatography paper for this. This is great for separating inks, like in a pen or a marker, and we'll actually do that in class. We'll do some chromatography. It's kind of cool to see. And so this is separating it based on its movement across the surface. So I'm going to pop over to a picture. If you need to pause this, please do. Here's an example. And so what you're seeing here is if you will put a dot of ink on this paper and you put it in some water, the water will actually run up, and maybe you've actually seen this before. Maybe you had a paper of something that actually got wet and the water spreads across your paper, and all of a sudden your ink starts to spread out. Well, you didn't mean to do it, but you're actually doing chromatography there. So we'll look at it in class, and you actually can separate out the colors of ink. Alright, yay, we're finished. So that's separating the mixtures and the 4 different ways we'll do it in here, and we'll talk about it more in class. Alright.